Assalamu alaikum students. Today we'll discuss the past paper problems from the sequences and series. And in our today's lesson, we'll attempt questions involving trigonometric functions. Okay. The first question is from May June 20. Paper is 1-3. Let's start. The first term of the progression is this. Theta lies in the first quadrant. The second term of progression is this one. Okay, so when we write these progressions, sine square of theta is the first term. Second term is sine square of theta into cos square of theta, and so on. In A part, the progression is geometric. Find the sum to infinity. When progression is geometric, then we find the ratio, which is called common ratio. Common ratio has the formula second term divided by first term. As it is mentioned that sequence is geometric, then ratio would be same. So there is no need to verify it. So we write T2 over T1, and from this formula we'll find the ratio. And the other thing in this part is sum to value of R is equal to sine square theta into cos square theta, and we divide it with the first term, which is equal to sine square theta. When you cancel the value of R, it is cos square of theta. Next is sum to infinity. Value of A is equal to sine square theta and divided by 1 minus R. And we have the value of R, which is equal to 1 minus cos square. Here we use the basic trigonometrical identities, and which is equal to 1. Sine square theta plus cos square theta is equal to 1. So if you make sine as the subject, so it is equal to this one. This implies that sine of infinity, sum to infinity, is equal to sine square theta divided by 1 minus divided by sine square theta. We have used this identity. So sum to infinity is equal to 1. Let's move to the next part. Next part of the question is, it is given instead the progression is arithmetic. Find the common difference of the progression in terms of sine of theta. D is equal to second term minus first term. This is the formula. As the sequence was sine square theta, sine square theta into cos square theta. When you plug in the values, it is sine square theta into cos square theta and minus sine square theta. Sine square theta is common, which is equal to cos square theta minus 1. We have used this identity in the previous part, which is equal to 1 minus cos square theta. But in the bracket, we have cos square theta minus 1. We can directly write the answer even, but I'm taking minus as common, and then it becomes 1 minus cos square theta. Minus, take minus outside, minus sine square theta, and replace 1 minus cos square theta with the identity, it becomes sine square theta. This implies that D is equal to minus sine 4 theta. This is the difference. Next part is find the sum of first 16 terms when theta is equal to this one. Okay, as we are dealing with arithmetic progression, then sum of n terms of arithmetic series is n by 2 into 2a plus n minus 1 into d. And we need to use the value of theta, which is pi by 3. As a is equal to sine square theta, and when we use the given value, in trigonometric function, when you substitute the value, it is recommended that sine pi by 3, take the power as a whole power. Sine pi by 3 by using the calculator, you would get this answer, under root 3 by 2 whole square. So A would be equal to 3 over 4. Likewise, we find the difference. As we have found the difference in the previous part, it is minus sine 4 of theta. So we write it sine pi by 3 whole power 4 minus under root 3 by 2 power 4. So it is 9 over 16. So this is the difference. We have D and we are finding the first 16 term. It means N is 16. So 16 divided by 2 into 2A. A is equal to 3 by 4 minus 15 times of D, 9 over 16. It is 8 bracket 3 by 2 minus minus plus 135 over 16. Taking the LCM, that's it. This is the question. Let's move to the next question. Okay, this is the question from February March 21, paper 1-2 variant. And the question says the first term of the progression is given, which is cos of theta. So let's take A is equal to cos of theta, as A is the first term. For the case when the progression is geometric, the sum to infinity is given. So this is the value of sum to infinity. Show that the second term in uh, is cos theta sine square theta. As we know, the formula for sum to infinity is equal to 1 minus r. If we look into the formula, we have A, we have sum to infinity, so r is missing. If we find r, then definitely we'll be able to find the second term in geometric progression. Okay, let's find r. So sum to infinity is equal to 1 over cos of theta, which is equal to cos of theta divided by 1 minus r. Cross multiply the term. 1 minus r, it is equal to cos square theta. And r would be equal to 1 minus cos square theta. This implies that r is equal to sine square theta by using the identity. Identity is sine square theta plus cos square theta is equal to 1. In this part, we need to find the second term. In geometric progression, the nth term formula is AR n minus 1. T2 would be equal to AR power 2 minus 1, which is AR. Value of A is cos of theta and value of R is equal to sine square of theta. This implies that second term is equal to cos of theta into sine square of theta. This is our answer. Okay, let's move to the other part. Find the sum of the first 12 terms when theta is this, giving the answer correct to 4 significant figure. Okay, so in this part, we have the value of theta and we need to write our answer into 4 significant figure. And the formula for sum of first n term in geometric progression, let's write it is Sn a into 1 minus r power n divided by 1 minus r. In this formula, we use the value of a and the value of r. Okay, as we have the value of a, it is equal to cos of theta, and theta is given, which is pi by 3. We can find the value in the numerical form. It is 1 by 2. We have found the value of r, and this was sine square of theta, and it is sine square of pi by 3. Whenever you have trigonometric function with the power and you need to find the value at some given value of x, then you write the power as a whole power. Then r would be square of under root 3 by 2, which is 3 by 4. Now we have the value of a and the value of r, and we need to find the sum of first 12 terms. So by taking the values into 1 minus r, which is 3 by 4 power 12, and we divide it with 1 minus r, which is equal to 3 by 4. We can use the calculator to find the answer. 1 by 2 mean 0.5 bracket, and 1 minus 3 by 4 can be written as 0.75, and the power is 12. And here close the bracket and go to the denominator, and 1 minus 3 by 4 is equal to 1 by 4. So here I can directly write it 1 divided by 4, and when I write my answer, so my answer is equal to 1.9366. See, as we need to write our answer into four significant figures, so take the value from the calculator up to five significant figure and then round it to four significant figure 1.937. So this is our answer, which is in the form of four significant figure. Okay, so this was the second question of the same type. Second part of the question says that for the case where the progression is arithmetic, find the first two terms. The first two terms are again cos theta, and these. Let's write the sequence first. It is cos of theta first term, cos of theta into sine square of theta second term, and we need to find the 85th term when theta is given. Basically, this is 85th term, so we'll find it by using the nth term of arithmetic progression, which is Tn a plus n minus 1 into d. Okay, in this formula, we'll be needing the value of a and the value of d, as n is mentioned that we need to find the 85th term. Let's find the values first and then plug in the values into the formulas. As a is equal to the first term cos of theta, and when we use the value of theta, which is pi by 3, and answer would be equal to 1 by 2. And for the difference would be equal to sine square theta cos of theta minus cos of theta, and when you take cos of theta common, so it is sine square theta minus 1. Again, we use the identity here, and that identity I'm writing at the top is sine square theta plus cos square theta is equal to 1. If I make cos square theta as a subject, it would be equal to 1 minus sine square theta. But in the bracket, we have sine square theta minus 1. Let's take minus common. I'm writing minus outside the bracket. It is equal to 1 minus sine square theta, which is equal to minus cos theta into cos square theta. Finally, difference is equal to cos cube theta. At the value of theta, pi by 3, difference would be equal to minus cos pi by 3 whole power 3. It is 1 by 2 power 3, and the value of d becomes minus 1 over 8. Now we have the value of a and the value of d. So these are the values of a and the value of d. As we need 85th term, so when you replace n with 85, it would give you a plus 84d. By substituting the values, 1 by 2 plus 84 into minus 1 by 8. It is minus 84 over 8. By using the calculator, you'll be able to get the answer which is equal to minus 10. So here, this completes the question. Now we move to the next question involving the trigonometric function. Our third question of today's lesson is from November 21 and the variant is 1, 2. The first term, third term, fifth term of an arithmetic progression are given. Okay, let us write all the terms. As the first term is given, it is equal to 2 cos of x. But the second term is missing, we'll write it as t2. Third term is equal to minus 6 under root 3 and sine of x. Fourth term is missing and then we write the fifth term. We need to find the exact value of x. Okay, the method which will apply here, third term minus the first term is equal to fifth term minus the third term. You must be thinking that how could you make the difference equal as we are dropping the middle term? Let's take an example to clear this concept. Like 4, 7, 10, 13, 16, 19 and 22. So these are few terms in arithmetic progression. If I omit the middle terms 7, 13, 19, let's see what do we get if we take the difference of 10 minus 4, I mean the difference of first and third term, and difference of fifth minus third term, and the difference from the seventh term, which is 22 and minus 16. If you find the difference, you would find that the difference are same. So this is the concept. In arithmetic progression, you can take the difference like this. Okay, let's solve because we need to find the value of x. Third term is minus 6 under root 3 sine of x minus the first term which is equal to cos of x. Then equal sign fifth term is 10 cos of x. Third term is negative and we have the minus sign in the step so it becomes positive. So 6 under root 3 sine of x. Now simplify these equations. You can see that sine is on both sides, cos on both sides. So when you simplify it, you will get the expression, the equation in form of tan. It is minus 6 under root 3 sine of x minus 6 under root 3 sine of x is equal to 10 cos x plus 2 cos x minus 12 under root 3 sine of x is equal to 12 cos of x. We can cancel 12 and when you write cos on the other side, this would be the final result. Tan of x is equal to minus under root 3. So tan inverse of minus under root 3. Let's use calculator to get the answer. By using the calculator will give us this answer. But this is not our required answer. Why? Because our answer lie in the second quadrant. So what do? We show the quadrants. Negative angle would be in the fourth quadrant, which is equal to pi by 6. As tan is negative in the second quadrant as well, so we show the same angle in the second quadrant. When you subtract it from pi, you would get 5 pi by 6. This implies that x answer would be minus pi by 6 and 5 pi by 6. Our final answer would be 5 pi by 6 as x is greater than pi by 2 and less than pi. That's why we take our answer x is equal to 5 pi by 6. So this is our answer. This is the exact value of x. Okay, let's move to the second part. Second part says that hence find the exact sum of the first 25 terms. Okay, this is very important part because this part involves a very special concept as we are dealing with arithmetic progression. When you write its formula says Sn is equal to n by 2 into 2a plus n minus 1 into d. So this is the formula. We need to find the sum of first 25 terms. So S25 would be equal to 25 over 2 into 2a plus 24d. The problem is to find the value of a and the d. As we have 2 cos of x as a is equal to 2 cos of x, and at value of x 5 pi by 6 will have the value of a. When you use the calculator, your calculator will give you this answer: minus under root 3 over 2. Minus and this will be cancelled. So value of a would be equal to minus under root 3. This is the value of a. Now for d, come to this example again. If you take the difference between first two terms and the difference is equal to 3, and the difference between the third and first term was 6. Okay, so how do you get the difference 3? You write 2 time of difference is equal to this, as you are taking the difference of third term minus first term. Okay, 2d is equal to 6. When you divide 6 by 2, so your difference would be 3. The same concept will apply in the next part. Like we'll take the difference 2d, and 2d, the third term is minus 6 under root 3 sine of x minus 2 cos of x. At x is equal to 5 pi by 6, we'll have 2d is equal to minus 6 under root 3 sine of 5 pi by 6 minus 2 cos of 5 pi by 6. 2d is equal to minus 6 under root 3 sine 5 pi by 6 will give you answer this one. Minus 2 cos would be equal to minus under root 3 by 2. 2d is equal to minus 3 under root 3, and 2 is to cancel, and it is, when you cancel 2 with 2, it becomes under root 3 plus under root 3. By subtracting minus 2 under root 3, finally d would be equal to minus under root 3. So this is the difference. Now we have the value of a, we have the value of d, and now we plug in all these values in the sum in this formula, which is sum of first 25 terms. S25 is equal to 12.5 into 2a. A is equal to minus under root 3 and plus 24 times of value of d. It is 12.5 minus 2 under root 3 minus 24 under root 3, which is 12.5 into 26 times of this value. When you multiply the numbers, you'll get 325 root 3. So which is the exact answer? This is what we need to find, exact sum. Okay, so this is the exact sum. Thank you very much, students.